So Vinayak, over to you about your background.
Yeah. So, I mean, although you kind of described me as a person with security background, I mean, the truth is, I jumped into security fairly late in the game, right? So it's, I've been associated with security only in the last, I would say, 3 years or so. But my background primarily stems from like database management, data management broadly. Um, so built a whole bunch of database systems. Always worked on the bottom half, if you will, right? Building database systems, building query systems, and so on. A bunch of different places. Building like SQL databases and so on and so forth. So for about 20 years. And about in 2013, I founded a company called X15 Software, which was targeted towards event data, log data management, machine data management, right? And the way we approached the problem, although like coming from the data management side of things, the gap we observed was there were a bunch of products that were built for short-term analysis of data, but nobody was doing like extremely long-term and interactive analysis. So X15 kind of approached the problem as data is growing, but also the working set is growing, which is if I need to look back 6 months, I need to look back 13 months, and I want interactive analytics, right? What are my options? There weren't that many, right? In fact, even today, I would argue there are not that many. So it turned out that the place where this sort of a system became the most useful was for security, right? Like if you look at event data, where do they come from? Event data mostly is like, you have security logs coming from products. You have, APM like systems like application performance monitoring, which produce, logs from your application, and you're trying to figure out why my performance is not good and things like that. Or it's infrastructure monitoring, where you're trying to predict the next failure in your data center. Now, if you look at the last two things that I mentioned, it turns out that you need interactive analysis, but the window over which you do that analysis is extremely short, because you don't really care what happened 6 months ago. Most of the time you care about what is happening in the last 7 days, or even shorter than that. Because the truth is, your machines or your application is not conspiring against you, right? On the other hand, in the security space, you never know how long an attacker has been trying or what techniques they've been trying, and so on and so forth. So a lot of times, look back is extremely important. So when you see a signal, you need to corroborate, and you need to go back as far as you can afford to with the data you hold. And of course, the amount of time spent by the analyst is the most expensive commodity there. So how quickly they can get their results, essentially. So it turned out that, long story short, X15 was useful for security. And that's what we saw, like 100% of our customers were using it for security analytics. And eventually, the company got acquired by FireEye. And basically, I spent 3 years at FireEye. That was really my intense, security education, if you will, right? So that's my kind of foray into security, if that makes sense.
So, in terms of walk through an example of how your X15 software would detect an anomaly or intrusion or someone getting into the systems through this application log.
Right.
Output.
Yeah. So so let's talk about essentially, like a broad approach that is used in security, right? Is you have a bunch of logs. Now, logs are essentially nothing but, subject, verb, object, right? Which is this user logged in to this machine, or this user sent this email with this email address to these recipients, and the content is so much. So essentially, you can essentially envision it as a graph that connects a bunch of nouns with verbs. And of course, they're not isolated events, right? They're all connected. They're like, you logged into this machine, then you perhaps, moved across into this other machine, and then you copied a file. I mean, there's like a whole bunch of, it's essentially a whole movie that's playing out over time. Mm-hmm. Right now, in the security world, there are things called IOCs, right? Indicators if you will, which are like, think about IP addresses, right? Like known IP addresses that are sources from which specific attack groups use malicious tools to get into your system, right? Or there are SHAs, or like the hashes of binaries, which are known to contain malware, for example, right? And so essentially all these signatures, if you will, are things that are kind of well known and kind of constantly growing, essentially dictionary of indicators that are useful to find needles in my haystack of logs, right? I mean, pretty much every detection tool uses some strategy that involves indicators and I wouldn't say logs, but using runtime runtime data of this sort, right? So and it's all about timing. It's like, how quickly can I look into it, and how far back can I look with my growing dictionary of indicators, right? So one of the things that, for example, like X15 could do, and which was extremely valuable to our customers, was over time. I mean, they had something like you can imagine, like in a decent org, if you are truly good about data collection, you can very easily get to 18, 20, 25 terabytes of data a day, right, in terms of collection. Now, as go back 30 days, 60 days, 90 days, 13 months. I mean, that's a lot of data, right? A lot of like just noisy data. I mean, the logs themselves are very low signal to noise, if you will, right? But really what's important is being able to take my dictionary of indicators and very quickly looking in my, this large sea of logs to find those needles, if you will, and say, have I seen logs that had this IP address or this SHA, or what is the connection between them, and kind of lift that data out very quickly, right? So this is something that X15 excelled at, right? Yeah, just as one example, yeah.
And I think I will let Tyler jump in around. Maybe I'll ask the leading question: how, from your prior experience in building these database designs, how important was data maps for you, and how have you seen data maps become effective or useful for organizations from a data governance side?
That's for me?
Yeah.
Yeah. Okay. So one of the biggest challenges, as I said, I mean, I think I said this earlier, decent organization which collects all the data. Part of the problem is data is being generated everywhere. Systems are being used everywhere, especially with this democratization of, like if I'm working for a company, I can very easily swipe my credit card and sign up for a service and start using it, right? Now that's a source of activity happening, the nouns and the verbs that are happening in my organization. And it's you don't have eyes and ears on everything, right? And this is partly the challenge. Like one of the reasons, in my opinion, why this whole log analytics for like conquering security has not been successful is because it's very hard to even put your arms around all data sources, right? So I mean, governance is the next step, which is, okay, you at least need to know that this piece of data is moving across these borders. Like, for example, I mean, who knows what kind of, PII data is moving across company boundaries when it shouldn't, right? And so just getting your arms around these things and knowing where to tap and what data to collect, and kind of keep those systems updated, right? Because every day it's new, right? I go and sign up for today. I'm a developer. I want, I don't know, I want to use GitHub. I go and create a GitHub account. You have the organization has zero eyes and ears over this transaction that some developer did, but the developer has extreme power in being able to move data across this organizational boundary, right? So kind of even knowing which piece of data, what are the services I use, what pieces of data are in different places, what data is traversing across trust boundaries, I think is a very important question that needs to be answered before I can even ask about compliance, governance, and all the other things that you would want to do with data.
Yeah, I mean, I often think about governance data governance from the perspective of sort of flowing down various privacy laws and contractual obligations and to the data that you're using, and right, and how that data use is being regulated across different products that are being built on top of it. I'd be curious, Yasir and I have talked about what are some of the initial things that you can do if you're building a sort of governance infrastructure from more of a compliance perspective or from a privacy perspective. I'm curious from a security perspective, what's the low-hanging fruit? Like, what are the easiest things or the 101 level things that most organizations should be doing if they're beginning to build a sort of data governance strategy?
I mean, it's a hard problem, right? Because this, I think, on one hand, policy essentially means things have to become more centralized. But if you look at how organizations are moving, it's towards more agile behavior, decentralized, it's like what they call, essentially, people who do the work have the power to decide what tools they would like to use. And usually security and compliance tends to be an afterthought, right? Perhaps if you're at a large company with a large compliance organization, you probably have to go through approvals and so on to get your thing in place. But a majority of startups, majority of companies which actually are sitting on extremely valuable data don't have those resources to do that, right? So again, I think there are, since the solutions that people use are decentralized, I think this whole governance strategy needs to have a decentralized solution, right? So, for example, take for example, this is why I kind of like what what we're doing here, right? Which is, as a developer, I use Slack, right? As a developer, I use GitHub, right? And it would be great that when I sign up with this, instead of going through an approval process and looking at every check-in by somebody who doesn't understand technology, instead, if there was a little interceptor along the way that was kind of blessed by the organization, which could kind of inspect the traffic, right? And so there is the mechanism of collecting the essentially metadata and the data that makes it across these boundaries. But then there is a centralized policy enforcer, which kind of decides what to do about what's happening, right? So I think the eyes and ears need to be decentralized for the data collection part, and then of course the policy needs to be centralized. That's just how I see things progressing here.
Do you think that, I think a lot about how, as an organization is thinking about data ethics, right? And how data is being leveraged, having, systematizing it, I think is sort of the next level, but having culture, like really strong culture around that is also very important. Do you think from a sort of security and governance perspective that having a culture across your developers, right, across your engineering org, in which they actually want to turn to security or want to turn to compliance or think of that as a partnership? Do you think that that's important? How do you think that you build that?
Yeah, in my opinion, all of that comes down to incentives, right? So, just think about, you hear about breaches, right? What you don't hear about is, so what, right? At the end of the day, if I'm running a company, if as long as we can write off security intrusions as cost of doing business, nothing's going to change, right? So at the end of the day, what does a developer stress about today, right? It's like, oh, if I introduce a bug in the system, I'll be woken up at 2 a.m. So I'm going to be extremely careful about introducing bugs into the system, right? So I do unit testing, I do integration. It's not because we love doing unit testing and integration testing. It's survival, right? It's like self-preservation, if you will. So I think we need to really start thinking about, move that all the way left, right? Like they call it shift left security, which is you start moving security down the pipeline all the way to development. But I really think until there is tangible impact to developers and their teams due to security impact, I think little is going to change in some sense.
How would you think about creating some metrics or some sort of these incentives, how would that look like, for example, for a developer base within a company? Is it like, how would you measure how secure you are in terms of how you do your job? Like, how would that look like? Or have you implemented something in your past which seemed to have worked?
Well, I mean, there are two classes of things, right? Like, let's talk about what is the basic set of like hygiene things that one should do, right? And in my opinion, like a lot of teams don't follow those basic things, right? Like, for example, today, I mean, as a developer, like I've been a developer for a long time, right? And I've seen a change in how development happens. So, a long time ago, when you built software, you curated the libraries. I mean, all the libraries that you used were under your control, right? The languages and just the build systems and the ecosystems didn't make it conducive, or made it extremely hard for there to be public registries of libraries which you just pulled at random, right? Whereas over time, what has happened, I mean, if you look at these different ecosystems, like, let's say, like, Node.js, right? For example, like the whole NPM registry. I mean, you essentially have a semver version in your package.json file. And when I build my system, it is pulling from who knows where, what library, which version. I mean, as a developer, you have very little visibility, although you have extreme control over what gets done. Just the way things have evolved, you're pulling code, foreign code that you do not control, right? So in the name of convenience, in the name of just managing your SDLC, like the software development lifecycle, we have essentially degenerated into kind of delegating or giving up agency of even controlling our source code, right? And that's a scary thought if you kind of pause and think, right? Like, I mean, you're so careful about what you install on your laptop. You run an antivirus, you run some kind of, you're extremely careful about who you give your email addresses to and your phone numbers to and so on. But on the other side, you have a build system that's pulling foreign code, which who knows what it contains, right? So this is a kind of a thing we need to kind of somehow come to terms with, right? So what do you do? Okay, so scanning, right? Static analysis. There are a whole bunch of static analysis tools for pretty much every language that you can think of, right? So static analysis is important. The second is paying attention to CVEs the moment they come out, so you can analyze impact, try to figure out what it means to your product, and update your libraries as soon as possible, right? But in general, I think just like we have unit tests and integration tests, I think pushing this left, like static analysis as part of your build, for example, right? But then again, as we saw recently, that's not a panacea, right? Like you saw the whole SolarWinds breach. What happens if my build system itself is compromised? Then, all bets are off, right? So again, it's a hard problem, and I don't think there is a single answer, but it's more about who in your organization is stressing about it. And if it's not everybody, you have a problem.
Could we talk a little bit about practically how policies that are maybe written by a mix of compliance and security are ultimately implemented across big data sets, and how you think that implementation works best? Sometimes it feels like those policies are written and put on a shelf as opposed to written and implemented. So how do you think that implementation works best?
Right. I mean, again, if you ask me, I don't think most of those, like there is a huge disconnect between coming up with the policy and actually making sure they're implemented and so on, right? I think, I mean, it's probably there is a lot of effort being put into it, but effectively, I think there are gaps there, in my opinion, right? But at the end of the day, here is the challenge. It's coming up with the policy is a non-technical job. It is done by people who don't actually understand, not necessarily not understand technology, but they don't live and breathe the technology or the actual systems the way they're built in an organization, right? So what happens is, yeah, somebody's sitting in an ivory tower and coming up with policies, but basically taking that and mapping it back down to the layers of your stack, layers of your software, is an extremely hard problem, right? And it's unclear. And I mean, first is just translating that down to what does, at the end of the day, when a developer is making a decision, how does that decision, how does that impact any specific entry in the policy? I mean, that's an extremely hard problem to even try to understand, right? Unless every developer understands what the policies are and what the spirit of the policy is in some sense. The converse of this problem is assuming, I mean, just like I'm going back to unit testing, right? Which is you need to have some kind of objective metric so that you can analyze and say, okay, what's been implemented is consistent with policy. So it's extremely hard to come up with tests to say, if you pass these tests, you are compliant with our policy, right? Again, partly because the people who come up with the policies are not technical, so they don't think like QA people, if you will, right? So I think there's a whole bunch of like, things that trickle down, and at every point there is some kind of loss in what the person was thinking, right? In some sense. So part of it, I come back to, again, I take holistic views of how systems are designed, right? Like in some sense, my philosophy building software has always been, if you cannot test something, you probably have to revisit the design, right? So I would argue that instead of retrofitting security and all of these policies that we talk about into existing software, I would take a more bottom-up, like from scratch approach, right? Which is when you're developing the software, build it in a more modular manner. Every part of it is testable. There is a very clear boundary. This whole move to microservices kind of facilitates that quite a bit, right? Although it adds other complexities. At least you know what the API looks like, and if there is no API, you're not accessing that data, right? So some of these principles, I think, in my opinion, are useful because you can apply the classic data strategies from the past, right? Like masking and hashing and encryption and so on at various levels. So as a developer, you're kind of shielded from some of the choices you might make and problems you might introduce in some sense.
I think this idea of QA being the ultimate decider if data governance policies are being implemented properly is pretty fascinating. Just in terms of, for example, one of the things we Tyler and I often talk about is data ownership. Who owns the data? Who is responsible for this data? Even the derived form for that. And maybe an example could be potentially around QA, where is the data being pulled from, what parts of the databases, what environments, and who's in charge of that, and where is it going to, and just being able to map those two pieces out, which could be done in a QA environment in many cases, and obviously in some cases it cannot, could be a good starting point in terms of, from a privacy by design principles of data ownership and users of that data, those two big components.
Yeah, so I mean, that's, I think, one of the problems that you highlight is this, right? Again, QA works with internal data sets that may or may not cover all the cases that you potentially care about, right? So I think the traditional role of QA, which is run a test or, to verify, kind of falls short, right? Because your systems are running 24/7, they're subject to data that is constantly changing. So I look at QA in a more continuous sense, right? Which is, can I have my tests? Look, I mean, we are in the cloud today, right? Resources are not at a premium like they used to be in the on-prem world, where I have to squeeze every bite of every ounce of performance from my hardware. Today, what you can do is you can have alternate systems that are watching the systems that are running, right? So you could actually have systems that are constantly looking at how other systems are accessing data and deciding whether that's a policy violation or not in conjunction. So in some sense, I would argue your product needs to have two layers, right? One is the business logic, and then there is the policy, like the what I'm calling QA, as basically watching what's happening dynamically at runtime on the real data that customers are using, if that makes sense.
Yeah, no, that's actually very interesting.
Content.
Vinayak, what are you working on now? What's the latest venture? Talk to us about
that. So It's so essentially I'm back into my data management roots. I founded a company in June called Mark 5 Software. So I'm building a essentially it's again log data management for machine data management, but basically coming this whole view of things are moving into the cloud. And one of the truths is that the amount of data is growing. I mean, the same concept, except that the focus is on how do you reduce the cost. Like if you look at if you believe that data is growing, and not just the data is growing, but the working set, as in the amount of data that you need to look at for doing things, is growing. And at the end of the day, this is just a cost to your business. How do you reduce that cost, right? So basically, I'm looking at cloud native architectures for doing data analytics on machine data, or security logs, and application performance monitoring logs, and so on and so forth. We are in the process of just releasing our product. It's called Mark 5 Search, and it is essentially an OpenSearch compliant product that runs on top of Google BigQuery, right? So OpenSearch, which is a fork of Elasticsearch, it has an API on which multiple security companies have built their products. Multiple APM vendors have built their products. So we implement the same API, but the underlying substrate, it's built on BigQuery, which essentially gives us unlimited scale, extremely low cost of operation, and purely cloud native. So you only pay for what you use. You don't keep running machines when the system is not being used.
That's interesting. So how is that problem not being currently solved?
I think technology is constantly in a state of flux, right? So I would say in the last 10-15 years, Elasticsearch basically became extremely popular as a non-SQL data system for being able to do search and just unstructured analytics. When Elasticsearch was built, it was built to be run on-prem, right? Where status quo was you basically pull together a bunch of systems, bunch of machines or VMs, and you scale out in that world, right? But I think in the last 5-10 years, I think there has been this whole other stack that has come into existence, right? Which is like Amazon has S3, Google has GCS, which are cloud native storage systems, and decoupling compute and storage has immense benefits, especially when you need to scale each of those independently of each other, right? Which usually tends to be the case in data management solutions. Like you don't want to have as many VMs running that are dictated by your storage footprint. You want to decide how many VMs you want based on compute, and you want to decide how much disk space you use based on storage. The problem with aggregated storage and compute, like what I call how on-prem system machine comes with so much CPU, so much memory, and so much disk. That's the aggregation. I think it kind of forces you into a corner with kind of being unable to scale one without also scaling the other, right? On the other hand, if you go towards more cloud native architectures where you separate compute and storage, your data is in a data plane which scales